This week's Fix It Friday is about drawing diagrams to show hydrogen bonding. And I put on the original post that this would be a 4-mark question. To be honest, this could be anywhere between 2 to 4 marks, depending on your exam board, depending on what they are marking you for, and how generous they're feeling at the time. I'm marking currently for Edexcel, and they're actually only giving a couple of marks for this type of diagram. But I have seen OCRB, for example, in the past give it 4. So either way, it's not hard to get 4 marks. It is worth making sure that you can do it. And this diagram is barely hitting 1 mark. So what are the problems with this diagram? Well, for a start, that isn't a molecule of methanol, so do be really careful that you're reading the question carefully. That is a molecule of ethanol. A number of times I've also seen just 2 water molecules when it's actually asked for something else. Okay, other errors which I didn't show because I thought it would be too obvious, but I have seen hundreds of times when marking exam papers is the good old OHO. So OHO does not exist, as you might imagine, but it certainly does exist in the minds of stressed A-level students when they're taking exams. So really try to avoid the OHO situation. Okay, so maybe this diagram isn't looking quite so bad if we take out the problem with the methanol, but actually it's really struggling. So where on earth could you get 4 marks? It's quite similar to a mechanism in that we should be always talking about lone pairs and dipoles. But it could be kind of confusing to decide which lone pairs and which dipoles are relevant, because if we're putting them all in, that's not necessarily efficient of our time. The other thing we need to consider is the bond angle. So what they have got right in this diagram is they have got the correct atom, the hydrogen, between the 2 oxygens. But actually the angle between these 3 atoms, so we've got an O which is bonded to the H, and then a hydrogen bond to the next O. So I want you to start your hydrogen bond diagrams like that, with the H in the middle, and that angle is 180 degrees. There is a very special bonding interaction going on here. It's not just a normal permanent dipole. There is a little bit of overlap of atomic orbitals with that oxygen that is on the right hand side, and that's what makes the hydrogen bond so strong compared to other intermolecular forces. That means the angle is important. The rest of the angles are not such a problem, and so when I'm drawing the rest of the molecules in, being methanol, I could just simplify and stick a CH3 on there, or you could display it. With my water, I'm going to try and draw it so that the angles are roughly 104.5, but it really isn't as important as getting that angle. Okay, so we've got the angle. What about dipoles? Well, dipoles, which ones do we draw? In this diagram, they've drawn the ones on the water molecule, but they've not drawn, really you would consider this dipole here to be the most important, because it's the polarity of that hydrogen, the delta positive, that is attracting the oxygen from the water molecule. So you definitely need that, and as a minimum I would also put maybe a dipole across my water molecule. Do you know what? It doesn't hurt to put in the other one as well, but the main thing is to concentrate on the 3 atoms. So that's going to be 2 oxygens and 1 hydrogen, or maybe 2 nitrogens, maybe an oxygen, hydrogen and a nitrogen, you know, it depends. We can get them between various different atoms, but the 2 electronegative atoms with the hydrogen kind of sandwiched between them, get those dipoles on. And then lone pairs, again, you might be thinking, well, there's more than one lone pair, what do I need to worry about? We need to worry about the lone pair there. So that oxygen, again, it's not a dative bond. A dative bond would be like 10 times stronger than a hydrogen bond because covalent bonds are really strong, but it is a pair of electrons that is being attracted to that hydrogen. So it's like a very small partial covalent bond, and therefore that's why we include that lone pair. So that's how we get full marks on our diagram. 3 dashes between them to indicate the actual hydrogen bond. To be honest, you could do more or less than 3 dashes, but 3 is usually the convention. So I'm just going to remind you again that my free webinar on the 4th of July is on calculations in A-level chemistry. So if you're in year 12 going into year 13, calculations are really going to ramp up next year. And so that is giving some hints and tips on how to cope with the calculations on the next level. And of course, there's practice exam style questions and videos on my website.